Hello everyone, myself Sagar Ramesh Kutte, working as Assistant Professor, Department of Physics, GMD College, Sinnar, Nasik. Now, last lecture we will discuss division of quantum number, electronic configuration, exclusion principle and Hund's rule. Now, in this lecture we will discuss origin of spectral light and selection rule. Now, first will be the origin of spectral line. According to the third postulate, when there is transition of electron from higher energy orbit to the lower energy orbit, the photon of energy h mu is emitted. Let us consider the transition of electron from higher energy nth orbit of lower energy mth orbit. Then the energy quantum emitted is given by h mu is equal to En minus Em, where En is energy of electron in nth orbit and Em is energy of electron in mth orbit. In equation, h mu is equal to minus m e raised to 4 upon h epsilon 0 e square h square n square minus bracket minus m e raised to 4 upon 8 epsilon 0 square h square m square. Now rearrange this equation. Mu is equal to m e raised to 4 8 epsilon 0 square h square. Now will be the common bracket 1 upon m square minus 1 upon n square. But C is equal to mu lambda, where lambda is wavelength of spectral line, c is the velocity of light. Thus above equation we get 1 upon lambda is equal to m e raised to 4 upon 8 epsilon 0 square ch cube bracket 1 upon m square minus 1 upon n square. The quantity 1 by lambda is equal to mu bar is called as wave number. Mu bar is equal to r into bracket 1 upon m square minus 1 upon n square bracket complete, where r is relations constant and it is given by r is equal to m e raised to 4 upon 8 epsilon 0 square ch cube is equal to 1.097 into 10 raised to 7 meter, that is meter inverse. Hydrogen spectrum consists of following 5 series of spectral line. This diagram indicates energy level and series transition for hydrogen atom. This figure shows the energy level of different series transition of hydrogen atom. In an energy level diagram, each Bohr orbit or stationary state is represented by horizontal line. Vertical scale is term wave number, that is mu. The energy value of quantized state are negative and approach to 0 as the principle of quantum number n increases. In this diagram, 5 series, that is Lyman series, Balmer series, Poisson series, bracket series and P-Fund series. Now first will be the Lyman series. This series exists when there is transition of electron from initial orbit n is equal to 2, 3, 4 up to infinity to 5 to final over orbit m is equal to 1. Wavelength of spectral line of this series lies in the ultraviolet region. Now second will be the Balmer series. Balmer series of spectral line of Balmer series are observed when an electron transition is from initial orbit n is equal to 3, 4, 5 up to infinity to final lower orbit m is equal to 2. This gives the visible region. H alpha line transition of electron from n is equal to 3 to m is equal to 2. H beta lines, transition of electron from n is equal to 4 to m is equal to 2. H gamma line, transition of electron is from n is equal to 5 to m is equal to 2. And H delta line, transition of electron from n is equal to 6 to m is equal to 2, and so on. Now third will be the Paschen series. For this series, electron transition is from n is equal to 4, 5, 6 up to infinity to m is equal to 3. Spectral line lies in the near infrared region. 4 will be the bracket series. For this series, electron transition is from n is equal to 5, 6, 7 to m is equal to 4. Spectral line lies in infrared region. Fifth will P-fund series. For this series, electron transition is from n is equal to 6, 7, 8 to m is equal to 5. That is, it lies in far infrared region. Now this will be the 5 series. The spectral wavelength calculated using Bohr relation are in good arrangement with the experimental observed wavelength for hydrogen atom. This is good success of Bohr theory. Now this will be the origin of spectral line. Now next topic is selection rule. Selection rule limits the occurrence of transition of only between certain pair of level. In other words, the condition of state between them transition occur are called as selection rule. Since the transition probability is proportional to Ck bracket T square, the probability of emission or absorption is proportional to the square of dipole matrix element. As already seen, for allow transition, the dipole matrix element mu Kn must be finite. In selection rule, there are two rules: spherically symmetrical potential and harmonic oscillator. First will be the selection rule for spherical symmetric potential. For a particle moving a spherically symmetric potential, the wave function psi n by m is equal to constant RNL bracket R PL raised to m cos theta is equal to e raised to im phi. Consider electromagnetic radiation moving in the x direction and polarized in the z direction. In this case, we have evaluated the dipole matrix element of Ez is equal to E r cos theta. The resulting integral will be the one in r, theta and phi coordinate. The integral in the coordinate r will be the non-vanishing. Whatever be the value of n and l, the integral in the phi is equal to integration 0 to 2 pi e raised to I bracket m minus m dash bracket into phi into d phi will be non-vanishing only if m dash minus m is equal to delta m is equal to 0. The theta integral is equal to integration 0 to pi pl m dash cos theta into cos theta plm bracket cos theta into d bracket cos theta into d theta is finite only l dash minus l is equal to delta l is value plus minus 1. If the radiation of polarized in the alternary direction, there will not be change in the selection rule, that is delta l is equal to plus minus 1. However, the selection rule is m changes to delta m is equal to plus minus 1. Therefore, if the radiation is polarized in the arbitrary direction, that is delta m is equal to 0 or plus minus 1 or delta L is equal to plus minus 1. Now second type will be the selection rule for harmonic oscillator. Consider change particle with changes E simple harmonic motion along x-axis about the point at which opposite changes is situated. The dipole moment at the instant is Ex. The wave function for the system is given. Dipole matrix element mu Kn is equal to constant integration h suffix n bracket x into x h suffix k into bracket x exponential bracket m omega upon h cross into x square into dx. From the properties of harmonic polynomial, it can be proved that the integral in equation non-vanishing only k differ from n by the plus minus 1. This gives the selection rule delta n is equal to plus minus 1. Selection rule play important role in spectroscopy. Now in this lecture we will discuss origin of line spectra and selection rule. Thank you so much.